Everybody, I'm Dick Wall. I was, up until a few months ago, a confirmed Flash and Flex and Apollo skeptic, mainly because I'm a Linux user and have been felt left out in the cold by Flash and Flex for a number of years. And then I met James, and he encouraged me to take another look at it, and I figured if he can do that for me, he can probably do that for just about anyone. So James Ward, he's a evangelist for Adobe for the Flex, Flash, and Apollo technologies. This tech talk is going to be a publicly released one, so please no confidential questions, and with that I'll hand over to James.
Great.
So take it away.
Thanks, Dick. So I am an evangelist for Flex. Must confess that I am not an evangelist like in the religious sense. I'm speaking about Flex because I have been a Java developer since about '97. I started building some applets and then transitioned to servlets, and then wrote the typical couple thousand line long servlet, and then got into struts and JSPs and all that, and found that I was having a really hard time creating applications, web applications that looked halfway decent. And so then, through a series of events, I found Flex and started doing some Flex development, and just fell in love right away with Flex, because I was able to create much better looking applications with Flex than I was able to do with HTML and JavaScript and those technologies. So I want to give you an overview of what Flex is, what Apollo is, what you can build with them, and then we'll actually write a little bit of code together so you can get a sense for the programming model behind Flex. So to get started, the first application that I want to show is one that we built as a proof of concept to show what we think user experiences should be like in web applications. And this is, of course, built with Flex, running in the browser. So this is an application that an insurance company would have to help a user enter information about an accident that they got into. So I'll come in and enter my policy information, my username and password, and then my driver information. You'll see that in this application there's these nice transitions between these different pages in the form. And I like to point out real quickly that we didn't just add these in to be cute and to be flashy. We really did it for a very specific purpose. And this is this type of application is showing you what what great user experiences are like. And we feel that by adding those transitions into this application, we really help the user to stay in context of where they were, where they are, how much further they have to go, so that the user can make this cognitive association with movement to say, I was there, I'm here now, and I know how to get to the next step. So it's a very important part of this application is those transitions. It's not just there for us to be cute. So I'm going to come in and select my vehicle now, and it's a Toyota Prius 2006, and it's gold. And here we see that car, my car, that I selected. And now I can begin to specify the damage that happened on this vehicle. So I'll mouse over the different parts of this, and I can say the hood was scratched, the front bumper was missing, and we can begin to detail all this information about what happened to our car when we got in this car accident. Maybe we could take it a step further and let the user even take out a pen and draw on the car to really illustrate the details of what happened to this car in the accident. And another thing I like to point out in this application is that this proof of concept was built not just to show how to build a better user experience, but also to show how rich internet applications not only do that, but also provide value back to the business. We don't just do rich internet applications to be cute. We do it for a very specific business purpose. And in this case, the business purpose is to get more and better information from the user about what happened in this accident. So, by allowing the user to just select the parts of the car and specify the damage, we're able to get better information from the user. So if you contrast this to a typical type of web form where it's a gigantic text field that says, describe what happened, and the user will say, well, I was on my way to work, I stopped by Starbucks, got a large cappuccino, and who knows what the user is going to enter in this text box. So by giving them a visual way to illustrate what actually happened, this provides much better information back to the insurance company. So then we take this to another level on the next form, where now we tell the user, all right, recreate the accident. So now we allow the user to take the car and drag it around the screen to recreate the accident. So they can say, well, I was coming from the north, I crossed a few lanes of traffic and turned right. This bozo coming from the other direction, he turned left, and boom, he hit me. And so, again, this is not just about the flashiness of it. It's really about creating a better user experience for the end user, and about creating about having more business value for the business that is behind this application. So, and feel free to stop me and ask questions as I go through this. But so this is kind of my best concept of what a rich internet application really should be. It should encompass both a great user experience, but also provide business value for that richness to the business behind it. So another example of some great stuff that we can do in rich internet applications is with Flex is to mash up Ajax and Flex applications to create some interesting things here. So this particular application, and that's because I don't have my webcam plugged in. So we'll get another one of those in a second. But this is taking a Flex application, combining it with Google Maps. So now I can sign into this application and into this one. And now these two users can collaborate in real time. So as one user takes the map and drags it around, we push that event in real time out to the other user's browser to change where the map position is. So that's using a real-time push technology, using a binary socket. And so it's not using a comet-style polling method. We're actually doing a real binary socket. If that binary socket isn't available due to firewall issues, we can actually fail over to a polling comet-style communication. So then this one's kind of cool. We can also kind of show off the vector graphics capabilities of Flex and Flash here. So I can now take the map and start drawing on it. One of the users can say, I think we should go this way, and the other user can go select a different color here and say, no, we should definitely go this way, and they can argue about the right way to wind their way through New York. So again, this is about creating a better user experience in this particular application, but also specifically through using real-time communication and real-time messaging. So that's another thing that we're seeing with rich internet applications is utilizing that real-time messaging to do interesting things like this. Another fun thing that we can do with Flex is we can get really flashy. But these aren't built with a typical timeline-based tool. They're built with what we call the open source, or what will be open source, Flex SDK. And it's free, will be open source by the end of the year. And so you can build really interesting applications by writing some code, which you'll see in a little bit. But in this particular one, the engineer that built this, he remembered when he was a kid having this anatomy book that had these transparent pages that you could flip through, and it would have different kind of layers of the body in it. So he thought that would make a great Flex demo. So he scanned in those pages and created this book component. So now you can take the book and open it up. You'll see that page the cover was hard. That's just a parameter on this component. But now we get the transparent page, and we can drag the page back and forth and flip the next one over too. So again, this is all just built with this reusable component. And because it's reusable, we can do lots of other interesting things. He has a number of other scenarios. I'll show a couple of them. This is all available on his blog, quietlyscheming.com. It's one of our Flex, actually the architect for the free Flex SDK. So this one is interesting because it shows how you can combine this book component with Flex components or with Flex charts. So now you can get a chart that's animating as we slide the page over, or even we could play video on a page. So you can really put any type of Flex component into this into the book component that you want. Switching gears a little bit, but still showing this component, I want to show how he then took the same exact component and used it within Apollo. So Apollo is our desktop runtime for web applications. So with Apollo, we're able to take HTML, Ajax, Flex, Flash, JavaScript, HTML, CSS, all that, and combine it into a desktop application experience. So he took his book component and is rendering a web page. So this is the real live Google here. We can search for the Java posse. And this is real live Google, but it is in the book component. So now we can grab the page, and oops, we shouldn't be showing Yahoo here. We'll go back. So here we can go somewhere else here. We'll load Java Posse in this other page. So there we get the Java Posse site, all again within this book component. So again, all just reusing that same book component, but this time pulling in HTML content. So I don't know if you would ever realistically use this for anything useful, but it's kind of a fun way to show component reuse. Yeah. How are we rendering HTML? So the Apollo runtime has both the Flash engine embedded in it, which is what we use for Flex, and it also has WebKit, the open source HTML engine behind Safari. So we combine those two technologies, and actually, I don't know how technical you want me to get, but what we do is we actually read how WebKit would output the HTML. We then take that and turn it all into Flash objects, and our ultimate end result is Flash objects in Apollo applications. So in Apollo, everything, the ultimate output rendering is all Flash, but we use WebKit behind the scenes to have a real HTML engine. So a couple things to note before I move on too much further about how Flex and Flash and Apollo work from a product perspective. Of course, Flash is a freely available download browser plugin. Flex 2 applications require Flash 9, which currently, in our latest statistics, after 9 months of being out, is at about 83–84% adoption worldwide. So you guys are probably all are familiar with Flash being kind of the de facto standard for rich interactive content on the web. It's the most distributed piece of software in the world. It has penetration. If we look back to, I think, Flash 7, the penetration numbers are at about 98% worldwide for Flash. So it's the most distributed piece of software on the web on I think 700 million different PCs and mobile devices. So this is why we have this great foundation to build these applications on. And we even recently have taken the core of Flash and now the core of Apollo and open sourced it with Mozilla. So if you're familiar with Mozilla Xamarin, that's the open source virtual machine that we use within Flash Player and within the Apollo runtime. So Xamarin now is open source with Mozilla. All that it really does, it's kind of the whole guts of our Flash virtual machine and of Apollo. It takes ECMAScript bytecode or ECMAScript code and just executes that within a JIT compiler. So there's some great benefits about having Xamarin and this JIT compiler available to us in our client applications. One of those is performance, which is another benefit here of Flash. This is an application that I wrote. You can find it on my blog, jamesward.org, and you can play with it on your own. But I want to compare the differences in data loading between Ajax and Flex. So within Flex, of course, we're using that Xamarin virtual machine. And then within the Ajax benchmarks, we'll be using just XML HTTP request, and I'll do JSON for you today, but you can play with the other methods. So what I'm going to do is I'm going to go to my server. I'm going to have my server generate 5,000 rows of JSON data, and that's just JavaScript object notation. Send that back across the wire, and then we're going to do an eval on that within JavaScript. And then we're going to take that eval code, our objects, and we're going to create an HTML table from those objects. So I'll run this, and we'll see how long that takes. So we measure 4 things: the server execution time, the transfer time, the parse time, and the render time. So total amount of time here for that 5,000 rows is about 2.5 seconds. You can see the various breakdowns there. But the parse time, interestingly, just the amount of time to actually do that the eval on that JSON string took about 1.2 seconds. And we can go see the actual output of this of that benchmark here. It's just an HTML table with all 5,000 rows in it. So you'll see all 5,000 rows. This one's just a plain old HTML table. It doesn't support client-side sorting. I did add a Dojo test because Dojo does support client-side sorting, but I won't do that test for you today. So the best method, there are various methods that you can use within Flex to talk to your backend to get data in. The best method is to use a protocol called AMF. AMF is a binary object serialization of our objects. So what happens is in AMF, we go to the server and say, hey, get me the same 5,000 rows, but encode it in this AMF format, which is pretty much the flash memory format. Then we send that across the wire, and then when we get it back on the flash side, we kind of just stuff it into a place in memory, and so that then we have all the objects available to us. So we're gonna, in this benchmark, we'll then render that data into the Flex data grid component. Yeah.
Do you trust that?
Do I trust what?
Well, raw binary data that's in the basically the structure format of whatever Flash is.
We do bounds checking on it before we actually throw it into memory. So, and there is a bunch of things where you can't overwrite, variables outside of the scope of that. So it's been in Flash since I think Flash 6 or so, and we haven't seen any security problems with it so far. So so I'll run this one. This one, same 5,000 rows. You'll see that benchmark only took under half a second there. So same 5,000 rows. The parse time is nearly nothing because we don't have to do a whole lot because it's already in the object format that we want within Flash. Then the render time, we're at only 63 milliseconds there. Yeah.
Okay, so you have some kind of integration into a Mozilla product called Tamarind.
Yeah, Tamarind.
It's going to go into Mozilla proper.
Yeah, it will at some point. So the Mozilla guys are working on integrating Tamarind into the Firefox browser. Yeah.
Okay, and you talk about JITs and you talk about binary and you talk
Yeah.
about performance. What does that actually mean? I mean, you've been buzzing by us here with a zillion fancy sounding words, but I haven't heard. What's the contribution here to a mainstream product?
You mean where would I use Tamarind outside of a browser or outside of Flash?
No, I mean, what will the contribution to the mainstream Mozilla actually be?
The main contribution was for a virtual machine. So that virtual machine is specifically for running ECMAScript code or JavaScript 2, or our implementation is called ActionScript 3. But that virtual machine is just a virtual machine. You could use that on your own if you wanted to, if you had needs for a virtual machine. But most people rely on a browser or Flash or something else for their virtual machine. So I don't know if that answers your question, but
so then will part of the contribution be a virtual machine for running, all the JavaScript in your browser faster in Mozilla?
Yeah, absolutely. Yeah, sorry, I didn't make that more clear. So the virtual machine does execute ECMAScript revision 4, which is the new standard for JavaScript 2. So when the browsers want to implement JavaScript 2 within the browser, then they will use the Tamarind virtual machine to actually execute that code. So rather than doing rather than interpreting JavaScript in their current virtual machine or how they do interpretation, they'll actually use Tamarind to execute that code.
Okay, so that applies to all that in Tamarind, and in the future in Mozilla, that'll apply to all JavaScript in the browser, which sounds
absolutely.
great.
Yep.
And at some point, are you going to talk about what the technology integration is going to be for Mozilla, in the future, or Tamarind today, and potentially Mozilla?
The roadmap that I've heard for getting Tamarind into Firefox is Firefox 4 timeframe. The reasons for that are, from what I've heard, are not technical. They are more that JavaScript 2, the language is different enough from the previous versions of JavaScript that it will break. That if we force JavaScript 2 on sites, it'll break some of them, and so they have to wait a while before they can transition people to JavaScript 2. This is something we could probably talk more in depth with Dion about afterwards, because he probably has more information than I do. But that's as far as I know about how the browsers are integrating Tamarin into the browser. Currently, the Tamarin is in Flash 9 today, and it is in Apollo today, and we use it for our code execution. Yeah.
You have a data bandwidth graph there, but do you have memory overhead?
Yeah, so I'm not, as far as I know, I'm not able to get memory usage in JavaScript, but I am able to get it within Flash. So the entire Flex application that we'll see in just a second, its memory overhead is about 25 megabytes of client-side memory. And then, of course, the bandwidth is here too. One of the interesting things about AMF3, the protocol, is that why it's so much less bandwidth is that what we do in the binary encoding is if we see a property that is repeated, we don't put that in the stream more than once. We just put a reference to that. So it's kind of like a somewhat of a gzip algorithm, but it's based on property values rather than on looking through ones and zeros for repeated strings. So that's why the bandwidth is much smaller, but that also does improve client-side memory as well. So let me go back to the Flex application. Here's our Flex data grid with all 5,000 rows. You'll see a lot of the strings in this particular data set are repeated. So that's why the bandwidth is so much different between Flex and Ajax in this particular use case. But definitely, depending on your use case, you may not see that same performance difference. Yeah.
So suppose I have several tabs, and I'm running different Flash applications.
Yeah.
So my memory footprint overhead is still 25, and it's shared across different tabs.
No, it would not be shared. Yeah, every instance of Flash on a page is a different instance of the virtual machine. So if you pulled in that same 5,000 rows in 5 different tabs, it would be 25 megs times 5.
Oh, okay. That 25 megs, is it Flash runtime memory?
It's Flash runtime plus. It's the entire Flash memory footprint for this application with the data grid. So it's the Flash runtime, it's the data grid, it's all 5,000 rows of data. All that combined is 25 megs of RAM.
Okay.
Yeah. So one thing I want to show real quickly, which you can explore further on your own, is that because of Tamarin and the fact that it's JIT compiled, if I increase this now to 20,000 rows, one thing that we can do because of the performance of the JIT compiler is I can sort all 20,000 rows entirely instantaneously on the client side. And that's something that if you try the Dojo test, even with 500 rows on the Dojo test, it takes I think 10, 20 seconds or so to sort 500 rows. So obviously we're using JIT compilers in Java and other languages because of these performance benefits, and that's what we're showing here is the performance benefits of Tamarin. So, and then we'll also see here that we still only took under a second to get that 20,000 rows to parse that or shove it into memory and then to render that into data grid as well. And we'll also see that the bandwidth is significantly less as well, still at only 345K for that 20,000 rows. So that's another reason why Flex and Flash and Apollo are interesting is the fact that right now we can take advantage of this Tamarin virtual machine with the JIT compiler. We don't have to wait until the browser adds Tamarin to speed up JavaScript. We can get this performance benefits now. So there's another example I want to show, which if you guys are Java developers, you may be familiar with the napkin skin that someone did for Swing a long time ago. One of our engineers did the same thing with Flex. So he was able to take our out-of-the-box Flex components, and with CSS styling and with some custom programmatic skinning, he was able to replicate the paper, the napkin skin. So this is kind of cool. It has all the typical things in here in the data grid, still works the same way as usual, but we get all the nice napkin-looking, feeling stuff here. So fun little application to show just exactly what you can do with skinning and styling. So Another application that I want to show is actually Google Finance. So Google Finance is, of course, one of your applications. And I always demo this application because it shows a great way to combine Flash-based technologies, Flex applications, and Ajax applications in the same, into the same experience. So here we have a very seamless user experience where we can get, we can go through the news on the right. This is all Ajax HTML-based content. And we have the Flash-based chart on the left. We can scroll through it. We get nice vector graphics, animations and stuff that you get with Flash. But then we can communicate back and forth between these two. So if the user selects something in the Ajax HTML content on the right, we can send that event over to the Flex or Flash application here, and we can do that bidirectionally. So we have a toolkit called the Flex Ajax Bridge that allows you to easily do this communication back and forth between Flex and Ajax. So it's not, we're not, with Flex, we're not saying replace everything with Flex. Ajax and HTML definitely have great places where they work very, very well, and we don't want to, tell you that you have to use Flex for those things, like HTML links and text, and these are things that HTML does very, very well. Flex and Flash, of course, are very good at vector graphics and performance and real-time messaging and those types of things. And so we can combine the two technologies together into a seamless user experience. Yeah?
I heard that there's been a limitation in terms of layering Ajax rendered content on top of Flash, Flex area. Is that still the case?
Interestingly, oh yeah, repeat the question. Sorry. So the question was, how do you layer Ajax and Flash or Flex technologies together onto the same page? And I believe that this works on all the browsers. I've tested it on Safari and IE and Firefox. I haven't tried it on Opera. But you'll see that this application, this benchmark application, is actually a Flex application that I built. But the output over here, of course, can be Ajax output as well as Flex output. So I did have to make that all work. So if we run one of these tests, this is HTML layered on top of my Flex application that you see. It kind of surrounds this now. But if we go back and run one of the Flex ones, that's doing the same technique, just overlaying another Flex application on top of a Flex application. So it's working here. The technique that we're using, there's a Flex component called iframe that allows you to do this, but we're just putting an iframe over top of the Flex application to make this work. And then you could still communicate back and forth via the Flex Ajax bridge.
Can you do a right click on two sides?
On which one?
On here, if you do right click, do you get the Flash?
This one is the Flex output. Let me switch back to a Ajax output, and we'll see the. So this is your basic HTML output here, and then of course over here is Flex application. And if we close that, then we're back to Flash. We just hid that iframe. We actually moved it up to the corner, up to a hidden area. I think that for some reason the browser, in order to actually kind of execute code within an iframe, it has to be like at least 1 pixel by 1 pixel or something like that. So I just hide it up in the top left corner there to make it work. It's kind of a hack. It took me about 2 days to make that actually work in all the browsers, but as far as I know, it does work pretty consistently.
If you do an iframe in the middle, can you do back? Can you do back like navigate through the jump through iframes?
Yeah. Interestingly, yeah, you could do that. You could navigate back and forward through the navigation within your iframe. Within Flex, we have a built-in history manager that does do an iframe on the page to then hook into the back and forward buttons within your Flex application. So this may not be the best example to show here, but Yahoo Maps has actually done a really good job at integrating this behavior into their application. So this is a Flex application, and if I get directions from San Francisco to San Jose, you'll see that it's changing the named anchor in my URL, but it's also hooking into those the back and forward buttons. So now I can go back and we restore the state back to the previous place without doing a page refresh. The bookmarks are all, or the URLs are all bookmarkable and can recreate the right state within the application. So you get that the back and forward kind of integration out of the box within Flex. There's also, if you need really customized behavior for back and forward, there is a open source toolkit called called URL Kit that makes it really robust way to integrate with back and forward within the browser and also manage the named anchors as well. So, yeah. All right. So. Let's see. So another application that I want to show is another Apollo application. This one is actually Google Maps. So we're transitioning from Yahoo Maps to your guys's Google Maps. What we did was we took Google Maps, and we're actually rendering Google Maps now within an Apollo application. So this application was launched from the Start menu. It could work offline if we cached everything locally in local files. But in this particular application, it's just pulling in all the Google Maps stuff live from Google. And we have also, over top of this, over Google Maps, we have a little Flex component. So here we can drag this little Flex component around. You'll see it's semi-transparent. We can now take a contact and drag it onto the map to get that particular location, navigate to that particular location. So this is all running, just as normal Google Maps would within the browser, but within an Apollo application that could be downloaded and installed and launched from your Start menu or your Mac dock or whatever. So, and some other people have started to do some interesting things as well, porting some of the other Google applications. Someone started doing Gmail, so now you could launch Gmail from an Apollo application. And I won't go all into that, but there's some interesting things, again, that you could do there. You could, within that application, you could actually intercept, like when it's getting mail sent over to the client, you could save that mail locally and do all sorts of offline things as well within Apollo. One application that is doing some of the offline stuff, which I won't show the offline portion today, but is a Salesforce application that we built. So this application actually goes out to Salesforce. It loads all of your customer data onto your local machine and even loads customer documents that you may have. So if you have documents for a customer or meeting information, it'll actually save all this locally. So then if I were to disconnect from the network, close this application, and launch it again, then I would still have all that same information synchronized locally. Actually, I have to tell it to specifically synchronize an account because we don't want to synchronize all my accounts unless the user specifies to do that. But this is all completely working, all synchronizing locally. This is something that Salesforce and us have been working on, and one of the great use cases for Apollo is being able to take your CRM applications or your business applications, be able to work on them while you're on the plane or while you don't have internet access. So that's all right. So I'm going to start writing some code to show you guys a little bit about how you build these Flex applications. So to kind of preface this, I'm using a tool that we charge for to build these. But everything that I'm building, you could use the free Flex SDK to build. So there's nothing special in this tool that you couldn't do with the free tool. The reason why I use the tool in this demonstration is that because of the code completion and because of the syntax checking, I'm much less error prone. So. But usually, I should also state, Linux is my primary OS. I usually just present on Vista because I can never be sure if I plug into the projector with Linux that it's actually going to work. But when I'm on Linux, I use Vim as my primary IDE and use Ant to do my builds and those sorts of things. So all using the free SDK. So I'll create a new project, and I'm sorry that I, again, have to use someone else's product, but we're going to create an application that pulls in some images from Flickr and renders those in a component that the quietlyscheming.com guy made to model the iTunes album art flipper. So I need to go include that component inside my library path. So I can just add it. There's a number of different ways we could include that, but I'm just going to add the display shelf here to my library path. And now we've got that component, and we can now build against, we can now implement that component in our application. So I need to take out my layout real quick. And so now I'm just going to use the default layout. And I'm going to add a Flickr service, which I'll show you in a minute. This is going to talk to Flickr for us. And then I'm also going to add a display shelf. And so the display shelf component is a reusable component that the quietlyscheming.com guy made. I'll set the data provider now, and I'm going to use a binding expression. So since Flex applications run on the client within the Flash virtual machine, what's going to happen is this display shelf is going to be watching this Flickr service for changes, and when it sees changes, it's going to automatically refresh to display those changes. So we're going to bind to f.photos, and so that's our photos array that we'll get back from Flickr. And then I need to add an event handler for creation complete. So creation complete gets thrown when the application is fully initialized. And so when we get the creation complete event, we want to call our Flickr service and call the get photos by tag method. And then I'm going to specify orange as the tag that I'm going to search Flickr for. So that's all we need in this particular application. So I'll save that, and it's just compiled that application into the Swift bytecode that runs within the Flash player. And now we can go in and run this as a Flex application. And so now we start to get some images from Flickr displayed in this display shelf component. So the display shelf, sometimes I have to close my browser rather quickly if anything obscene comes up, but looks like we're OK. I usually use orange because it's a pretty safe term. I tried Flex once. That wasn't a good idea. So I try to stick to orange. Ooh, that one's kind of obscene. So anyways, this is the display shelf component that Eli built. You'll see that it has the live reflection going on, has the nice transitions as we move between these photos. So that was only a couple lines of code to use that display shelf component and then also talk to Flickr. I want to show you a little bit about this Flickr service. The Flickr service, how am I doing on time? Well, I forgot to ask. 20 minutes. 20 minutes, OK, great. So the Flickr service is an ActionScript class. So with Flex, we combine the declarative XML, which we call MXML, with the procedural ActionScript language. And so this Flickr service is definitely more of a procedural type class. And so we wrote this in ActionScript. But this just talks to Flickr for us. So you'll see that the syntax is a lot like Java. It's the new JavaScript 2 syntax or ActionScript 3, whatever you want to call it. You'll see that we have our Flickr service class. We have a photos array collection that's set to bindable, meaning that we can use that in a binding expression like we did in our display shelf as the data provider. Here's the binding expression there. And then we also have an HTTP service, which is going to go out and make an HTTP call. Because remember, these Flex applications are running client side. So in order to get something from the server, we have to go over HTTP or some binary socket. So we have our HTTP service. In our constructor of our Flickr service, we set the URL. We set an event listener so that when we get a response back from Flickr, we call this handle result function. And then we just loop through the results and render and set those items as add them to our array. Then we also have our get photos by tag method, which just takes a string with tags, and then we create our request parameters our RESTful style request parameters that we want to send to Flickr, and then we do a srv.send. So that's a real simple class to talk to Flickr. One of the things that I like to show is kind of the difference here between MXML and ActionScript. So within Flex, everything is ultimately ActionScript. So MXML is just there is almost like a code generation language. So we take MXML actually, and we convert it into ActionScript. So everything that you can do in MXML, you could also do in ActionScript. ActionScript is our low-level language, and we just provide the declarative language because it's very easy to begin prototyping applications. XML is also very familiar to HTML developers, so we provide that as one way that you can begin building your applications. So you'll see that this block of XML is actually doing what would be just a single line of ActionScript. I could say, I could actually add a script block here. And inside my script block, instead of defining my Flickr service here, I could actually define it here. I could say var f, which is our ID, and that's a Flickr service. So you'll see that the typing in JavaScript 2 uses colons. And then we create a new Flickr service. So we could do it that way in the scripting code. This block does when it's code generation would look exactly like this. For the purposes of this demo, I didn't do it with the script block because it adds like 5 lines or 4 lines of code, and that 4 lines makes the demo not look quite as cool. So one other thing I want to show here is the debugging features. So we can also set a breakpoint. You'll see I've already set one here. Let's clear that, set it back. Can set a breakpoint now here so that if you did need to debug this application and see what exactly Flickr was giving you as a response, I can now launch my application in debug mode. And in debug mode, it automatically, I got my response back from Flickr, and now I'm in my debugger within Eclipse. This is integrated into the Eclipse debugger. I can see my stack trace, come in and see variables, set expressions, all the typical debugging things. So this kind of thing helps you be a lot more productive when you're building your applications. So that's kind of the development experience. I could keep writing code if I've completely confused you guys with that sample. Any questions before I move on? Want to see more code? Anything? Yeah.
Can you try to move your Flex code that's kind of browser to Apollo?
Good. Yeah, good question. So, oh yes, the question was how could I take this application and turn it into an Apollo application? So that's a great thing to show. We use the same exact Flex library, Flex compiler, the free Flex SDK, to build our Apollo application. So again, you could do this all with all the free tools. I'll do it here just for simplicity. But I'm going to create a Apollo Flickr app. And I have to, again, add to my library path that display shelf component. And I haven't tried this ahead of time, so hopefully it all works. But we could do a much better reusable model than this, but just for the sake of time, I'm going to just do the copy and paste reusability model. And so I'll just paste in this code into my Apollo application. So same exact code. I'll save that. And now let's run this as an Apollo application. Oops, I'm in the wrong one. Here we go. Run as an Apollo application. And now we've just launched that same exact application, which should be talking to Flickr and rendering images. No. Well, interesting. Yeah, I should have tried this one ahead of time. So that should be working. Not sure why it's not. Maybe my internet has problems. All right, let's try it again. Oh, there we go. All right. I was worried there. So here we have the same exact application now running as an Apollo application. And so the way that I just ran that was not the way that your user would run that. So let me show you real quickly the experience now for turning this into an Apollo application and then in some way that you could give it to your users. So again, this could all be done through an AMP build or however you want to do it. But I'm going to export this application as an AIR file. AIR is the Apollo installable archive. So now we can take this Apollo application, package it into an air file, and, oops, that's not the name I want. Let's call it flickr.air. So now I've just saved that into an air file. So the air file is what you would put on your website or email to somebody. And now when they get that air file, if they have Apollo installed, they can just double click it, and we launch the Apollo installer. So now we're going to say, do you really want to install this application? It's going to have access to do whatever it wants on your local system. Are you sure you're OK with that? I am OK with that. I don't want a shortcut on my desktop. Continue. And now I could run it now, but I want to show you launching it through the Start menu. So I'm going to tell it not to launch it now. But now we go to our Start menu, and here we have our Apollo Flickr. We can launch that application right from, oh, and those images were cached, so it went really fast. Well, that was kind of obscene. So that's the experience now for creating Apollo applications. What we're doing in the next version of Apollo, which will be out, the full release version of Apollo will be out sometime this year. But the version that's out now is an alpha version. The next kind of alpha or beta version will include the ability to offer your users the Apollo air file, or an MSI or a Mac, whatever the Mac installer is. So if the user doesn't have Apollo installed, then they can just download one file that will install Apollo, then install your application. And that's how we'll get a lot of users, installing Apollo. We have a lot of really interesting customers. I just found this one. The website last night. Let's go see if I can find it again. eBay is doing some interesting things with Apollo. Project San Dimas is the code name there. They actually have a site somewhere. There we go. So Project San Dimas, you could sign up for the beta on the site. But this is a full eBay desktop application built with Apollo. So it does some really interesting things. When you're offline, you can still see items that were cached. You can even post items while you're offline, and then when you reconnect, it will automatically submit your items that you've created to eBay. So there's some really cool things in this application, and we should be seeing public betas of this in the next month or so. Yeah.
So can I run this stuff on internet tablet or other processors?
The Apollo currently runs on Mac and Windows, and they're working on the Linux version, which should be out sometime after the 1.0 version, they've said. So as long as it's Windows or Mac, you'll be fine. Linux will be sometime in the future.
So could I eventually run on a Linux running on ARM processor?
I believe so, yeah. Oh, the question was, could I run this on Linux running ARM? And I believe the answer is yes. One of the reasons why I think ARM is, you're talking more about like mobile devices. One of the reasons, I'll give you a little secret information about Apollo. One of the reasons why we chose WebKit as our HTML rendering as opposed to Gecko was that WebKit is much more suited for mobile devices because Nokia has been investing a lot in WebKit. So that may give you some indication as to where we're going with Apollo. So that's so I would hope that the answer to your question would be yes. I don't know what time frames are. Yeah.
Will Apollo be first-class desktop citizen that you can do obvious things like copy and paste between other applications, like if I'm using Word and then
Right.
the copy text over to the Apollo application, will it work? Copy and paste the other way?
Yeah, yeah. So the question is how integrated can Apollo applications be with the desktop? So for 1.0, the things that you can do are you can read and write files to the local file system anywhere. You're not in a file system sandbox. You can catch online, offline events. You can do system tray notifications. You can do background processes. You can do copy and paste with native applications. You can do drag and drop with the native OS. And I'm probably forgetting a few things. But the main thing that you won't be able to do in 1.0 is talk to local DLLs. And there's a lot of people that really want the ability to talk to DLLs, but we're trying to figure out the best way to do that because we don't want to break the cross-platformness of Apollo. We want to maintain cross-platform.
You're not going to rewrite Acrobat with Apollo?
At some point, we might. Yeah, we have quite a few internal projects using Apollo currently. We announced just a couple weeks ago the Adobe Media Player. That is an Apollo application, and there's a number of other internal Adobe projects right now going on that are using Apollo. Yeah, question in the back.
Yeah, is there any DRM doing the Apollo?
What was that?
Is there any DRM?
DRM in Apollo. Not at this time. Some people have asked for it. Some people have asked that we never add it, and I'm not sure what the current status of that is. The Adobe Media Player definitely has some kind of DRM, but it's not anything that was built into the Apollo runtime itself. So they implemented it on top of Apollo. Yeah.
What about 3D?
What was that?
What about 3D? There was a project called Atmosphere a few years ago.
Atmosphere. We used to have a project called Central. Central was kind of the predecessor of Apollo. It was a desktop runtime for Flash applications. But now with Apollo, we're not just about Flash applications. We're about Ajax, HTML, JavaScript, and Flex and Flash applications. So.
Is this with 3D?
Oh, 3D. I'm sorry, I misheard you. 3D is not something that is currently supported. It's something that they're looking at adding for future versions of both Flash and Apollo. But at this point, if you want to do 3D, actually, today within our interestingly, that Xamarin Virtual Machine is fast enough that some people have done some really interesting things. There's this project called Papervision 3D that's an open source project that does 3D within, I don't know if this is the right one. Yeah, it looks like it might be. So they've created a 3D engine or 3D-like engine on top of the current Flash 9 virtual machine, and we'll see if we can find a little demo here. Here we go. So this is running within Flash 9. We have I'm not a real 3D guru, so I don't know everything that's going on here, but this is just able to happen through the performance of Xamarin within Flash 9. So, and this is an open source 3D library. I've never used it, so I don't know all the details, but supposedly it's pretty interesting. Other questions? Yeah.
So you mentioned that most of Apollo applications in the example you said it gives you full access to the disk. Does Apollo support any sort of sandboxing?
I don't know what the total story will be for 1.0. I don't even know if we're sure yet what the story will be for 1.0. We're definitely working on a signing model, so you'll be able to sign your Apollo applications. And I don't know exactly how we're going to implement that as far as different sandboxes for signed applications or not. I don't know if we even know yet what we're going to do there, because it's a pretty complex problem. We've found that that once a user, I think somebody was telling me we did these user studies, where as soon as the user clicks the button to like download or run an Apollo application, it doesn't matter what dialog box we put in front of them. Even if it's like a gigantic like hazard sign saying like this thing will destroy your computer, people completely ignore it, and if they want to install it, they will. And so we're trying to figure out, all right, what does this mean to creating a security model that actually works? And even like this has been one of the problems with Java and signed applications, is that if a user wants to install something, if they think that it's something that they want to install, they don't care what the dialog box tells them about what this application could do to their computer. So we're trying to figure out exactly what the best security model there is.
For sandboxes, what sort of language level protections are there to keep programs from escaping the sandbox? And what sort of assurance do you, what sort of QA do you do to make sure that the sandbox can't be breached?
That's a good question. So what kind of assurances do we make that the Apollo applications can't escape the sandbox? And I don't have a whole lot of information about that, but I think the best answer to that is that if you look at Flash's history of how well its sandbox has been, and that I don't know if there's been an occurrence of anyone breaking out of the Flash sandbox within the browser, that we're putting the same kind of scrutiny on Apollo to make sure that it's just as secure and as the Flash player has been. So that's, I'm sorry I don't have more technical details for you, but I would hope that we have the same team working on doing the security testing against Apollo that do the Flash player. So we should be similar situations. Other questions? Yeah.
Am I right? First application is normal JavaScript without static typing.
Without, good question. So I didn't really go into the typing. So the JavaScript 2, ActionScript 3, ECMAScript 262 revision 4, that language allows you to do optional static typing. So you can type your objects if you want to. You don't have to. That's something that I could actually show real quickly here, is in our ActionScript code for our Flickr service, I can take a type off. We'll take this type off, and things will compile just fine, but I'll get an additional compiler warning, which I could disable if I wanted to, telling me that hey, this isn't typed. Maybe you should look at typing it. But yeah, you can mix and match typing as you want to. Yep. One more question, and then I'm out of time.
You mentioned the AMF3 stuff. How do I generate that? Is that part of Flash?
AMF3?
Yeah.
Yeah. So AMF is a protocol that's documented on osflash.org. There are numerous open source and free implementations of it. One for Java is called Granite Data Services. There's also OpenAMF. There's AMF PHP and Red 5 and lots of implementations out there. We have a commercial product that if you really want to purchase, you can. But there are open source implementations out there. So yeah, good question. Thank you. All right, well, I think I'm out of time. Thank you all for coming. Hope you learned something.